Hi guys. Today we are going to be going over algebraic reasoning, and that is why I have made this PowerPoint blue because it matches the color of your tears. No, I'm kidding. Algebra is not that bad once you kind of understand the basics of it, and thankfully we are not going too deep into algebra, so you should not cry, but I can't make any promises. If you're the kind of person who cries easily, maybe you will. So you might want to grab a tissue for this lesson today. Um, but all jokes aside, we can start with our problems. So our first problem, we are just drawing graphs based on scenarios that we are given. The first one is draw a graph to correlate with the function of the amount of gas in a gas tank when a driver refills the tank. So this one, there's a lot of ways this graph could have went, but I just went with the basic. He's filling his tank. So I'm going to say he didn't start from zero. I mean, maybe he did. We've all been there. But I'm going to assume that he had a little bit of gas in his tank when he went to the gas station. So I did not put it exactly on zero. And I have started the line right here on the amount of gas, and it just steadily goes up while he's filling his tank. Now, if I would have continued with this, maybe I would have drawn a straight line right here, because for a little bit, maybe a split second, he would have a full tank of gas when pulling on the gas station, and then we all know what happens. It'll go back down. Time is going to stay on the bottom because time is constant no matter what, and this line is always changing, so we can't have time be on that axis. Okay, this one we are drawing a graph for an elevator. Elevators, they stop and then they go up, and then they stop and they go up, and they stop and they go up. So basically, this is just kind of showing, it looks like stairs, which makes sense for an elevator. Again, time would be on the bottom because time is constant. Time is not going up and down and stopping as much as we might want it to stop or speed up. It's constant, so it's going on the bottom. This one is construct a graph to correlate the function basically of a bouncy ball when it's dropped. So this fun shape is called a parabola. It's a fun word to say. And the bouncy ball, it drops and then it comes right back up. And my line's not perfect, and if it was, it wouldn't be sitting there for a while, it would come straight back up. So we're just going to pretend that I drew a perfect parabola and that the ball dropped and came right back up right away. So, my bad. But we're pretending. And in this one, excuse me. I lost it. Okay, there it is. So in this one, we are doing a flagpole in the sun in its shadow on a perfect sunny day. And you know how long its shadow is going to be. So with time, let's say this is noon right here in the center, it would be the longest during noon, like the shadow would be, and then it would fall during nighttime and the evening and sunset, and then we would restart it again. Same with this one. If the ball bounced again, it would drop again. It wouldn't come as high, but it'd drop down, do another parabola, and then it'd drop down, and then, but maybe if we started from the table again, it would do the same pattern. And there's my summary, which I don't need to go over with y'all because I've already discussed it. Oh, gross. Look at this. What do you do with this? Cry, right? Blue tears? No. What we can do is we can go through this and we can pick out things that make this problem seem less scary, because when we see a lot of words and a lot of parentheses and a lot of letters, we're overwhelmed. But really, it's not that bad when you look at this problem. So if we just pick out the problem, we can see that F means in the equation that we are multiplying x by 3. We can do that. We see that G means that we are adding 8 to x. Again, we can do that. And then, so we get the equation 3x plus 8. And then, to make things even better, x is given to us. So it just makes it a simple algebra equation. And yes, there's such thing as simple algebra equations, at least as simple as it's going to get, because it's all downhill for here, and it's not a parabola. It's not coming back up to be easier. I'm sorry. Anyway, So we plug in the numbers. They gave us 0, 1, 2, and 3. And also, if you notice, it goes in a pattern here. We've got plus 3, plus 3, plus 3. And so we would know that if we line this up in a domain and range table, we could say that this was a function, but we're not getting into that. We don't need to go over more than we need to because, you know, algebra, right? Okay, so in this one we are trying to find the slope of lines based on, sorry, my little Zoom meeting thing is covering here. We're trying to find lines based on just coordinates, which is really easy. Again, we have a pretty little formula for that, and when we can plug in numbers in the formula, basic beginner algebra stuff, man. It only goes downhill from here, remember, so be thankful when it is easy. And so the equation is y2 minus y1 over x2 over x1. And the coordinates they gave us, I have written those right over here. And so first we'll do 5 minus 1. So we'll do y2 minus y1. And then x2 minus x1, which is 5 minus 3. And then we get 4 over 2. And simplify, that's just 2. And that's a diagonal line. Because it would technically be 2 over 1. But, you know, written down in the simple way, it's just 2. And we do the same thing right over here, but this one is undefined because if we divide a number by 0, it's 0, and a slope of 0 is a horizontal line that is undefined. Or is it vertical? It's vertical, I'm sorry. And then in this one, same thing as the first one. We're just plugging in those numbers to our simple little equation here. And let's go to the next slide. There we go. So this one, oh, look at this pretty parabolas that Kat tried so hard to draw pretty. Yay! Again, we're going to pretend they're perfect. They're not, but, you know, imagination. It's important. So for this one, when you see a number that is squared, like x is squared, it's more than likely going to be a parabola. And if it's like negatively squared, then it would go the other way. But with these are just a squared number, and then we're adding on the x-axis. So it's, you know, x squared plus 7. So we move, this is the original one, you know, it's on the origin, which is 0, 0. And then we add 7, so we just move it over 7. And on this one, we're taking away 7, so it's negative 7. So we're just moving it over 7 the other way, and it's that simple. And then if we had a number in front of x, it would either make the parabola skinnier or fatter. And next problem, we are doing perpendicular lines, and perpendicular, for just a bit of a reminder, is when two lines meet at a perfect right angle. Sorry, I spaced there for a second. And so this is where we use our little equation here. Again, very important that we know equations because we can't escape them. So we might as well learn them. You might as well become friends with them because they're going to make things easier for us, even though they seem like the opposite. So they have given us this equation and these coordinates. So to find the perpendicular line, we're going to find the negative reciprocal, which reciprocal is just kind of the opposite, like we're flipping it. So for this, we'd flip 3/4, negative 3/4, to 4/3, and the negative means we're just basically multiplying it by 1, or negative 1, excuse me. Or you can just see if it's a negative number, we're taking away the negative, or if it's a positive number, we're adding the positive. Adding the negative, I'm sorry. And then we have our coordinates, our x and y coordinates right here. So we're going to go ahead and plug those in. We have y and x, and that would just leave us with b, because that's what we're looking for to find the perpendicular. And then we solve for b, and there's our equation. Same thing over here, but a little bit of a difference is that, excuse me, my Zoom menu is in the way. Let's move. Hello. Can you not be there? There we go. So for this one, the equation is kind of out of whack, but you know, we can put it exactly where we need to put y by itself on one side and x and b on the side together. So that's what I've done. I've turned this equation into this one. So this one just had one more step than the other one, but it's not hard to fix an equation the way we need it to be. And then we just do the exact same thing that we did over here. We find the negative reciprocal slope, and then we find b, and then we get our equation. Okay, so for this one, we are finding the equation of a line that is tangent to the circle. And so, and the origin is 0, 0. Origin is always 0, 0. That's never going to change. And then we plug it into this pretty little equation here. This one's not so fun. When I said it only goes downhill from here, well, we're starting to go downhill here if you haven't noticed. But so we just plug it in and we get y equals 9. And over here we get y equals 9. And these lines would be negative 9, sorry, and this one's 9. And these lines would be parallel to each other because they are not negative reciprocals. And the slope is going the same way, just on different points of the x-axis. And that is all I have for y'all. Thanks for bearing through this algebra. I hope your face is not as blue as my PowerPoint. And if it is, well, take a hot bubble bath, grab a glass of wine if you're 21, and just, you know, pat yourself on the back for making it through here because we have done it.